Okay, quarter 3, week 4, day 3. Find the quotient. Okay, once again, we're doing division. So we're going to do keep, change, flip. 8 over 9 times 7 over 3. All right, let's see. Is there any cross reducing we can do? Well, there's nothing that goes into 8 and 3. There's nothing that goes into 7 and 9. So we just have to use what we have here. So 7 times 8 is 56. 9 times 3 is 27. Okay, so how many times does 27 go into 56? Well, 2 times. And then 2 times 27 is 54. So we've used up 54 of the 56. So how much is left over? Well, 2 out of 27. So the quotient is 2 and 2/27. And there's our answer. Now we have to find the sum, and sum means we are adding. Okay, so we have to just line up the decimals. Adding and subtracting decimals, you have to line them up. So let's go ahead and just move this one over. I'm going to put the 1 underneath the 7, the 8 then, and the 9, and the 2. All right, so they're lined up now, and we're just going to kind of act like this doesn't exist over here. We can put the zeros here. We don't need to. So 3 plus 0 is 3. 0 plus 0 is 0. 7 plus 1 is 8. Okay, there should be a decimal here. Line up the decimal. 8 plus 4 is 11. Nope. There's 12. And then we have 9 plus 5 and 1. So basically 9 and 1 is 10, plus 5 is 15. And then 2 plus 1 is 3. Bring the decimal. So there's our answer. 352.803. Sorry for the quick little brain strain in there, but 352.803 is the sum of these two numbers. Jesse ran 4 miles in 1 hour. How long did it take Jesse to run 1 mile? All right, so we already have it down here, 1 hour. It was 4 miles in that hour. All right, so how long did it take Jesse to run 1 mile? So we're not going to 1 hour. We're converting it down to the 1 mile. So what does it take to get from 4 down to 1? Well, you're going to either multiply by 1/4 or divide by 4, right? So 4 divided by 4 is 1. So you have to do 1, either multiply by 1/4 or divide by 4. So 1 divided by 4 is 1/4 of something. So it's going to be 1/4 of an hour. Okay, and then we know that there are 60 minutes in an hour. And so an hour is divided into 4 sections of 15 minutes. So we can just say 15 minutes for 1 mile, right? So 1 mile will take 15 minutes. All right, there we go. So it's either 1 mile is a quarter of an hour or 1 mile is 15 minutes, and either one of those would be good answers. How many yards are there in 2.5 miles? Well, I'm showing you here that one mile is 1,760 yards. So if we want to get from 1 mile to 2.5 miles, okay, what would we have to do that? Well, we'd have to go 1 times 2.5. So all you have to do to find out how many yards, you take that many yards times 2.5. Okay, and if you do that, you're going to end up with 4,400 yards. That's all you have to do. 1,760 times 2.5 gives you 4,400 yards. So that's the same. 2.5 miles is also 4,400 yards. All right, Joe has some money in his bank account. Okay, so he has some money in his bank account. They didn't tell us how much money, but he has money in his bank account. He deposits $45. Okay, to withdraw would be taking money out, so he deposited $45 in, put money into the account. Write an expression that represents the amount of money in Joe's account. Okay, So let's just pick a letter. We can make it X, I guess. That would be the amount of money he had in the account already. And then he put $45 in. And that would be the expression. Okay, so write an expression. This was the money that was already in there plus the money he added in there. So there we go. X plus 45. There's your expression. Lenny earns at least $50 a day. That's going to be important. At least $50. So Lenny earns $50 or more, I guess, because it's at least. It says write an inequality showing how much Lenny could earn on any day. Okay. Well, let's just use X again as our variable, representing how much he can earn in a day. 50 is how much he earns at least, right? So X is going to have to be equal to 50. Okay, so we're going to put that little equal sign, or it can actually be bigger than or greater than 50. So there's our representation. There's our inequality. X is greater than 50, or it could be exactly 50, which would be equal to. So that's all we have to do to write that inequality. All right, we need to find the rule and solve for n. All right, remember, we talk about input-output tables. You put X into a machine or something like that, and something happens to it, and it comes out the Y. So I'm thinking I can already see a little bit. I'm pretty sure I know what the rule is for this one already. Looks like it's pretty straightforward. Because if you do 4 times 3, that's going to give you 12. 6 times 3 is 18. 12 times 3 is 36. So to solve for n, we would just do the 7 times 3. So first, let's write the rule. The rule is y is going to be whatever x is times 3. So I'm just going to put 3x. So whatever x is, multiply by 3, that's what y is going to be. So there's our rule. And if that's our rule, then we just do 7 times 3. So n is going to be 21. All right, so there's our two answers. Our rule is y equals 3 times x. And then our actual answer for n is 21. All right, we are finding the volume on this one. And again, volume is equal to length times width times height. So I rewrote this. We have the 4.5 feet, and then we have the 3 feet and the 7 1/5 feet. So we're going to have to change these into improper fractions to be able to multiply across and then convert it back to a mixed number. So remember how we do that. 4 times 2 is 8, plus 1 more is 9. So it's 9 over 2. And then we have the 3, which becomes just 3 over 1. And then times 7 times 5 is 35. 35. Plus 1 more is 36. So we have 36 over 5. So there we go. At this point, we can see if we can do any cross-reducing. There is just a little bit of cross-reducing that we can do. Okay, because we can see the 2 is an even number, and so is the 36. So that's about all we can do. So let's do it. 2 goes into 2 once. 2 goes into 36 18 times. All right, so half of 36 is 18. So we're going to have to just multiply across. So we have 9 times 3 times 18, and that equals 486. And then with this one, we just have 1 times 1 times 5, which is 5. Well, we know it's not going to go evenly into it because 486 does not end in a 5 or a 0. But if we take 486 and we can see how many 5s go into it, there is 97 groups of 5 that will go into 486 without going over. So if we do 97 times 5, that's 400, 485. So we've used up 485 of the 486. So how much is left over? 1 out of 5. So, and the answer is going to be in feet cubed because it's volume. So 97 1/5 feet cubed. Okay, remember it's three-dimensional. So there's our answer, 97 1/5 feet cubed. Use the net to find the surface area of the cube. Well, they did tell us it is a cube, which means every single side or every side length of this is going to be 4. Every single side is 4. Okay, so with that being the case, if we were to, flatten it out into a net like we have here, then that would also be the case here. Every single side would be 4. Okay, so this would be 4 here, and on and on and on, every single side. All right, so with that being the case, it's going to be really quick to find the total surface area. 4 times 4 is 16, so each square is going to be 16 centimeters squared. At that point, we just count up how many squares there are. There's 1, 2, 3, 4, 5, 6 squares. So all you have to do to find the total surface area is do 16 times 6. 6 times 6 is 36. 6 times 1 is 6, plus 3 more is 9. So it's going to be 96 centimeters squared. So that is the total surface area. 96 centimeters squared would be the total surface area of this cube right here.